Hey there. I'd like to make a couple of comments about Lab 7. Now, the second part of Lab 7 talks about the sieve of Eratosthenes, which is a nice way to find primes. The idea is pretty simple. Right? So it goes back to the days of the Greeks. How do you find primes? Well, we don't worry about one, so let's just list all the numbers, 2, 3. So let's suppose we're finding the primes up to 20. What do? Well, we start with the number 2. And then we go every second one, which is basically the multiples of 2. So we cross out the 4, the 6, the 8, the 10, the 12, 14, and so on. Those can't be primes because they're all multiples of 2. We go to the next unmarked number and we start marking again. First one we mark is 6. It's already marked, but we can mark it again. So we go 6, 9, 12 marked, but we can mark it again. 15, 18 already marked, so on. And we go to the next one. There's a 5, and 2 times 5, we go over 5, that's 10, already marked, we can mark it again. 15 already marked, and 20 already marked. How about 7? Go over 7, that's 14 already marked. That's the last one we have. 11, double that is 22, 13, 17, 19, and we're done. And the ones I haven't crossed off, those are the primes. 1, of course, and then 2, 3, 4, 5, 6, and so on. 2, 3, 5, 7, 11. Notice how we mark them multiple times. In fact, I didn't even have to skip things. Like, so for example, I skipped marking with 4. I didn't really have to do that. I could have gone through and just said, all right, well, even though it's a useless effort, 4 would have marked off the 8 and the 12 and the 16 and the 20. And the fact that they were already marked isn't a problem because it's a little easier for my algorithm to just go through and mark them again. I know since all the multiples of 2 have been crossed off, all the multiples of 4 have been crossed off, but who cares? Doesn't matter. Same thing with 6. It's crossed off because of the 3, and all the multiples of 6 will have been crossed off, such as the 12 and the 18. And if I go and cross them off again, doesn't matter. So how do we do this in Python? Well, or how can I do it in any programming language? And the key idea is to use the indices as the numbers. Now, and our indices, however, start smaller than 2, right? Our indices start with a 0 and a 1. So I can have a list that starts at 0, goes all the way up to 20, and I just ignore the first 2. And now I can use my indices, and I can do my marking off in here. So how do I mark off? Well, things are either marked, right, or they're not unmarked. That's 2 things. I can call them whatever I want, such as a Boolean. We can call the false unmarked and the a false marked and true unmarked, or the other way around if you want to think that way. How do I start off? Well, I start off with everything unmarked, and I can unmark these. I can just totally ignore them. And what does it mean to mark them? Well, I go through, and to mark them, if I start with 2, every other one, I make it into a false. So that becomes a false, that becomes a false, that becomes a false, and so on. And with my marking that way, what am I left with is, oops, we better make sure this guy is not a true unless I want to completely ignore it. I end up with whatever is unmarked is a prime. All right, there's a little bit of an idea about this lab.